this is section 10.4. Please take notes. So you've already learned about this type of angle here in the blue. That's called an inscribed angle. And remember, the relationship was that angle ADB was equal to 1/2 of the arc AB, the measure of arc AB. So your angle was equal to half of your arc. Similarly, if this segment, instead of intersecting at 2 spots, if it was just a tangent, and actually only intersected at 1 spot, but you still had your chord, this relationship remains. So the measure of angle 1, your angle, is equal to 1/2 the measure of your arc ZX. So this angle 1 is half of your arc. And also the measure of angle 2 is equal to 1/2 the measure of arc ZYX. So just like we previously learned with inscribed angles, these are also going to be, your angle is equal to 1/2 the measure of your arc. So for example, let's look at angle 1. Notice our chord intersects our tangent, forming an angle. So again, your angle is equal to half the measure of your arc, and your angle is angle 1, and it's equal to 1/2 of 120 degrees, which is your arc. So your angle 1, is equal to half of 120, which is 60 degrees. That's the measure of angle 1. And in this example, I give you the angle, but I want you to find the measure of the arc. So again, your angle equals 1/2 the measure of your arc, and your angle is 140 degrees, so that equals 1/2 the measure of your arc. To get rid of this 1/2, if you multiply both sides by 2, it will get rid of this fraction here. 2 times 1 is 2, and then this will just cancel out to be 1. So you end up with 280 is equal to the measure of your arc. So this arc here in red is 280 degrees. Next, I need you to find the measure of this angle BCD. So using that same relationship, our angle is half the measure of the arc, and our angle here is 5x, and that's equal to half the measure of the arc, which is this 9x plus 20. Now you could distribute the 1/2 to the 9 and then to the 20, but that will leave you with a fraction here, 9/2. So instead of getting a fraction, I prefer to multiply both sides by 2, and then it cancels out this fraction. And you're left with 10x is equal to 9x plus 20, and using some algebra, you get x is equal to 20. Now you have to recall what the question asked. We want the measure of angle BCD. Well, if we know x is 20, we can plug this measure for x back into your equation here. So you plug 20 in for this x, and you would get 100 degrees. So the measure of angle BCD is equal to 100 degrees. So we have 3 different places where 2 lines can intersect on a circle. One of them is on the circle, which we've already discussed. Next, we're going to talk about the relationship if your lines intersect inside the circle, And then last, if they intersect outside the circle. So these intersect inside your circle. So for two lines that intersect inside, the relationship is that the measure of each angle is half the sum, the measure of the arcs. So what that means is that your angle here, let's say angle 1, this angle is going to be equal to 1/2. The sum means plus, it means to add, of the arcs intercepted. So arc DC plus, and then this arc over here on the other side is arc AB. So the measure of this angle 1 here is going to be half the sum of the two intercepted arcs. And for the measure of angle 2, it'll be very similar. Measure of angle 2 will be 1/2 the measure of arc BC, this arc here, plus the measure of arc AD. And these are all measure of arc. Let's do an example. So again, your angle is equal to half the sum of your arcs. So arc 1 plus your arc 2. This is if your segments intersect inside the circle. So your angle here we have is x, that's equal to 1/2. One of your arcs, which is 106 degrees, plus the measure of your other arc over here, 174 degrees. So let's add those two up. X is 1/2 of 280 degrees, or x is equal to 140 degrees. So this angle is 140 degrees. Make sure you notice that these arcs that you're adding, the measures, are what are formed from your segments. So this arc and then this arc over here. You're not adding up P, Q, and SR. Now for segments that intersect outside the circle. So we have 3 different cases, but you're going to do the same process for all 3. So your first case is if you have a secant. Remember, a secant intersects the circle twice, but a tangent only intersects the circle once. So one case is if you have a secant and a tangent that intersect outside the circle. The second case is if you have 2 tangents, they intersect once. So these are tangents. Or if you have 2 secants. Remember, secants intersect the circle at 2 different spots. So if you have a secant and a tangent, the relationship between this angle and your arcs are that your angle is equal to 1/2 the difference of the measures of the intercepted arcs. So this angle is equal to 1/2 of the difference. Remember, difference is actually subtraction, it's minus, and sum is plus. So right here we're actually going to take the difference. And notice that arc BC here is actually the bigger arc. So you're always going to do 1/2 of the bigger arc minus, and then the smaller arc. And then of course course, the same is true for these other two cases, just the arcs look a little different. So this arc actually goes all the way around, and then this one finishes it off over here. That's for two tangents, but you're always doing 1/2. Your angle is equal to half of the bigger arc minus the smaller arc. Your angle here is equal to 1/2 of your bigger arc xy minus your smaller arc wz. And this is for when they intersect outside the circle. So an example. Remember, our angle is equal to 1/2 of the bigger arc minus the smaller arc. And our angle here is 72 degrees. So that should be equal to 1/2 of whatever our bigger arc is, which is this 200 degrees. And that's minus the smaller arc over here, which is actually x. And to solve this, again, I'm not going to distribute the 1/2. Instead, I'm going to multiply both sides by 2, which will cancel your fraction out. If you were to distribute, you would have gotten a fraction over here. So 2 times 72 is 144. And that's equal to what's left over here, 200 minus x. So I would subtract 200 from both sides. And you have negative x left over here. And 144 minus 200 is equal to negative 56. And x is not by itself yet, there is a negative, so you need to divide both sides by -1. And you get x is equal to 56. So you found the measure of this smaller arc here is 56 degrees. All right, so here we again have two lines. These are actually tangents that intersect outside. So our angle, which is x, is equal to 1/2 the measure of your bigger arc minus your smaller arc. So our bigger arc here is major arc MLN, but I don't know the measure of that arc. So you need to use the smaller arc, which is 92, and if you know the whole circle is 360 degrees, you could take away the smaller arc, 92, and get 268 degrees for the major arc. So we've got x is 1/2 of 268 degrees minus the smaller arc, which is 92 degrees. And do 268 minus 92, and you get x is equal to 1/2 of 176, or x is equal to, when you take 1/2 of 176, you get 88 degrees. So your angle is 88 degrees. And that concludes the notes for 10.4.